started recording now. So this is part of the recording.
It's fine. Then we have a backup. Okay, Adam, take it away.
In progress. Okay. Oh, it shows it on the other scan. One moment. Okay, so everyone's seeing?
Yep, we see it.
Okay. So our next session is going to be about dynamic channel selection. I'm gonna lead the presentation, and Itay will take over in somewhere in the middle. First of all, to those who are less familiar with it, we'll go with a short overview of the feature, what is currently supported, future plans in the open source, and a few things that here in Intel we are in the Intel project we are planned. Under the hood, some going into details and some examples. And in the end, we will have a hands-on session that Itay will lead as well. So a short overview. The dynamic channel selection will from now on refer to TCS. Will provide the ability to scan the selected Wi-Fi channels list, neighboring IPs.
It's not obvious, right? Or it is.
It's obvious. It's just.
Sorry?
Well, MBDS is handy downstream.
Okay. So it provides the ability to scan the selected channels, the Wi-Fi channels, list neighboring IPs, and determine the optimal channel to work on. Of course, it can be triggered on the 2.4 gigahertz and 5 gigahertz radio. In terms of best channel of operation, so there are two modes. Passive mode. In that mode, all of the statistics can be retrieved by a third party, and according to some calculation at the third party, the best channel can be chosen. And in the active mode, the feature itself will select in the controller. They will do some calculation and then select the best channel and switch to that channel. The configuration available is dwell time. It's how long you're going to stay on each channel during the scan. Channel pool, the list of channels to scan, and the interval between scans. There are two modes of operation, single scan or continuous scans. The interval is for the continuous scans, how long you're going to wait between each scan operation. So I already covered the first bullet. Currently supported both the continuous and the single scan, triggering a scan and getting results from the driver, getting cached results. This is for the continuous scan mode. When you retrieve the result, you can retrieve results without actually performing the scan at this point. Just they are cached. Scan configuration, of course, and results are stored in the database. Currently, they are non-persistent. And the scan parameters validation is already implemented of the channel pool, dwell time, and interval time for valid values. In terms of the future plans, so like I said, currently the DCS parameters are non-persistent, but there's a plan to move them to the UCI. Define DCS active and passive states according to multiple chip configuration. I mentioned before that there are passive and active modes. So we can provide per chip configuration that during init will be read, and passive mode, what we have now, will just print a log. But in the future, when we'll support the active mode, it will can start the scans. But at first phase, we will just provide the ability to configure passive or active mode, and at the later stage, actually implement the active mode. Channel selection task, a task that currently isn't in use. We plan to remove this code. Dynamic channel selection task in the controller. Add active mode, like I mentioned. Run AOCS. This is automatic optimized channel selection. Just a word on that. This is a proprietary algorithm currently implemented in the host TPD in Intel. So the plan is to move this algorithm to the controller and make the decision making of best channel at the controller. So at first step is to implement this at the controller side, and of course later on remove it from the host TPD. Currently it's available there as a patch. So I'm moving to the start using non-VS SIMViews in dynamic channel selection task. Currently, all of the DCS messaging is vendor-specific SIMViews. So the future is to move, of course, to the EasyMesh R2 messaging. Build reference report.
It's actually EasyMesh R1. The R2 is only for it's partly R1 and partly R2. The R2 message has the possibility to trigger a channel scan, and it has a possibility to do CAC.
Okay, so thank you for elaborating on this. So of course we will call it to the R1 as well, but I mean that we will also need to meet the R2 requirements. And in the last, the builder preference report, so we saw in, I think, the session with Tomer, the list of operating classes and how they are divided by channels and everything. So according to the operating classes, there will be grading, and we'll need to build a preference report according to the algorithm of the AOCS. From the agent side, the agent will be responsible to create to make the decision according to the preference report that is received from the controller. At first phase, we will just perform a simplified preference report decision making, which means just to switch to the channel that was provided as best. But at the second phase, it can be any suggested logic that can determine from the preference report, even if we want a different channel, which we think at the agent that it is better. trigger DCS tasks on init in case of active state, as I mentioned before. Align DCS init sequence for Intel proprietary features. And remove the OCS algorithm patch from host TPD. One small note is that besides what currently the interface to the DCS or in general to the prpLMesh is in the BML, and but we also provide an Intel interface to the third party in the Wi-Fi HAL in RDKB, and there are some metrics related to the DCS that are missing there, so it's also in the future plans. So under the hood, I'll jump to the interface. All of this
Do you
command.
mind if I take it from here?
No, for slide 10, Itay.
Oh, okay.
Okay. So all of these commands here are prefixed with the BML underscore, but I removed that for easier display. So the interface provides you can set and get the continuous scan enable, and of course set and get the params mentioned: dwell time, interval time, channel pool, and channel pool size. The params configuration is per radio interface, just to be clear on that. So any configuration of the DCS is per band. For the single scan, in the command you provide the parameters using the start DCS single scan API. And if you wish to retrieve the results orthogonally to the scan itself, you can get DCS scan results. And the last parameter here is single scan. Sorry. Is single scan determines which result you're gonna get back, the ones for the single scan or the continuous scan, which are cached separately. This allows support for continuous scans and on-demand request simultaneously on the platform, because the results are cached separately and the channel pool can be different, etc. The third-party APIs are a bit different. They are correlating to the Wi-Fi HAL API or header provided in the RDKB. So you see here a much longer list, but the implementation of all of these APIs is using those BML APIs that were shown in the slide before. So no need to go into details here. Itay will take it from here regarding the task, database, etc. Itay, you want to present?
Yeah, just 1 second.
So a bit of a question.
Yes.
If there is a request from the controller to do a scan to a certain BSS, presumably the MAC addresses that you have there in the BML interface before, and you have continuous scanning enabled, will you then return the scan results, or will you trigger a new scan there and then?
So the single scan is, as I said, orthogonal to the continuous scans. Currently, there is no limitation of the interval time, but we might want to add in the future that if the single scan request arrived in the middle of the interval time, if you want to have some protection from hardware perspective, from the driver's perspective. But in general, unless there is currently a scan of the continuous scan, the single scan will perform the operation, finish, and when the continuous scan reaches the interval time, it will then perform its own scan. So not
like,
interfere with each
if
other.
the continuous scan is in progress and you're going to get results.
You get a status. I will elaborate on that in a moment.
Okay.
You get a status that the scan is in progress, and you will the operation itself will fail with the status of scan in progress.
Ah, okay. Yeah.
Basically, because we don't allow 2 or more scans on the same radio, yeah, so it will receive a scan in progress error. And actually, as you can see, the task basically is the main component of the DCS. What we do is we handle the request for the DCS in the task, and accordingly send a request back downwards to the agent and monitor. Basically, once results are ready, those results will be stored in the database, as well as the most current status of the results, as you can see accordingly. Basically, there's the success status, the internal failure, the channel pool too big, and as you can see accordingly to the presentation. Like I said before, once we decide to trigger a scan, the controller, aka the task, sends forward a message to the monitor, which is then being piped to the BWL, and from there it gets handled through the NL system and is sent to the driver. We access the NL and the BWL through 3 main APIs: the channel scan trigger, the process DWPAL event, which handles all incoming events from the driver to the BWL, and the channel scan dump results, which allows us to trigger cache result dump from the driver. What you can see here are examples of the types of results that we get back from the driver. The results are stored within the database once they are received in the controller, and can be accessed through third-party APIs, as you can see in the following prints, where they are restructured and printed differently according to the third-party specifications. What I want to show you is the flow of the DCS from the scan trigger to the scan finish, basically. So as you can see, the scan parameters are being sent from the controller and stored to the database. And while in the idle status, the scan either waits for the trigger signal scan, or checks if the continuous scan interval was expired. Either way, we fetch the DCS parameters like the dwell time and the channel pool from the database, validate them, and send them forward to the BWL. From there, those parameters are sent to the DWPAL as parameters, and we request a trigger scan. The response is sent back to the agent and is forwarded to the controller, which basically updates the status of the task. That way we can follow exactly what is the most current status of the DCS scan. When a scan is triggered, the NL basically notifies us that the scan was triggered, and we forward that event all the way to the task through the BWL monitor and controller to update the DCS task that the scan was triggered successfully and the scan is in progress. From from there, when the results are ready, we notify the active monitor and tell him that the results are ready. From there, we request a scan dump with the appropriate API, and also notify the task that the results are ready, and that also updates the files, the FSM. From there, for each result available, we perform the same sequence. A dump is received by the BWL. It is translated from a dump format to a structure. It is then being forwarded from the BWL to the monitor and all the way through the task, where it is stored in the database. This basically repeats itself for each result available in the driver. And finally, a dump finish NL message is sent. It is handled in the BWL, sent forward to the agent, all the way back to the task, which stores the most current status in the database. That way, we have all the results and their most current status safely in the database. Now, when we are requested from either the VROC CLI or from a third-party user, the results are being requested through the WLAN APIs, through the VML APIs, and from the controller, they are read from the database, and according to their status, they're either handled as an error or printed out as a result. And that's basically it. Any questions before we go to the presentation?
So for now, there is only an implementation that relies on DWPAL, right?
Yes.
How hard would it be to create a basic Netlink backend that doesn't rely on DWPAL for other platforms?
Currently, we basically handled only the NL system messages, but I can't say for sure. I can't say for sure because it all depends on the different implementations.
Why do you ask, Frederick?
Just curious.
Ask specifically, what do you want? Do you want to switch to what Marco did?
Well, we will need to.
I think we can switch to it, but it's more a request to Intel.
Well, actually, the question has two parts. On the one hand, it's is it using the DWPAL to retrieve the Netlink message or going directly to Netlink, which is actually a fairly easy one to change, so that's not really a big issue. The other part is, does it use a vendor-specific Netlink commands and events, or is it a generic Netlink commands and events? That one is more important, because if it's a generic one, then it can be used as is on any other driver. If it's a vendor-specific one, it only works on Intel chips.
Okay, so currently we do use only DWPAL. The DWPAL is actually sending the Netlink commands, but as you know, and what Mario did was actually same as DWPAL. It's not very sophisticated, and we can start using it. But the scan itself, it's currently vendor specific.
Okay, thank you.
Okay, In the presentation, I will show you an output results from the Virus CLI. Yeah.
How is asking some questions in the chat?
Oh, sorry, I wasn't looking in the chat. 1 second.
So for the first question, the unfamiliar acronyms, we do have a glossary page on our wiki. That should be some help. Yeah.
Okay. So I'm not sure exactly why I can't see the chat, but it's probably because I'm currently presenting.
Yeah, you should have a drop down, more options, and then you have chats. So you should be able to see it.
Oh, yeah, now I see it. Okay, so yeah, basically, I'm not sure exactly what acronyms you were having issues with, but no, so regarding question number 2, what triggers the DCS? Currently, we support the third-party APIs triggering the DCS, or the DCS can be triggered if the preset interval was ellipsed. Basically, both. 1 second. So, and regarding to number 3, currently there is no channel ranking formula. Where can so yeah, no. Currently there is no channel ranking formula. There should be one in the host APD patch, which we want to implement as our future. Yeah, we want to implement it in a future feature. Currently, it's not supported. Okay, so can I continue with the presentation, or are there any more questions? Okay. Actually, regarding number 4, you can see in my presentation, I'll be showing the results outputs in any minute, in just a second. I'm going to start with a simple single scan. Basically, what I start here is I request a single scan from the WLAN 0 radio with 30 milliseconds of dwell time, and the scan will be running on channel 36. So as you can see, 1 second. Oh. So as you can see here, the scan was processed and was triggered. You don't really see the results yet, because to see the results, you need to run the BML get DCS scan results with the same. You can as you can see, to get the results, you need to run the BML get DCS scan results with the appropriate MAC address. I've set the available results to 50, and the 1 represents that we are fetching the single scan results. So as you can see here, I just received about roughly 30 results, since it starts with an index 0. And basically, as you can see the results, you can see the SSID. The BSSID the current operating mode, the current channel at which the channel was scanned, which in our case it's only channel 36, the single strength, the security mode status, and the encryption mode status, along with the operating frequency band, supported standards, and the current operating standard, the operating channel bandwidth, as well as the beacon period, the noise availability, and the basic data transfer rates in kilobits per second, as well as the supported data transfer rates in also kilobits per second. As you can see here, the results are different from channel to channel, which doesn't really surprise, but yeah. So what I'm gonna do next is scan on the 2.4 giga radio.
Hi.
Yeah.
Hi. Can you show what is different, except for the SSID and the SSID?
For example, the security mode enabled for one, it shows a value of 3, which according to our enums should be, if I'm not mistaken, no, I'm not 100% sure what the enum number 3 is, but as you can see here, for other channels, the security mode is not enabled. Therefore, there are no available channels. And also, also you can clearly see the signal strength, which is different between neighbor and neighbor. And what I'm going to do next is I'm going to perform a single scan on the 2.4 gigas radio, also in in a dwell time of 30 milliseconds. But this time I'm going to scan 3 channels, 1, 5, and 11. So as you can see, the channel pool is different since I sent a different channel pool, and the result came back successful. So now I'm going to run the second DCS get scan result, the second radio. So if I run, now you can see there are, hello? Can everybody hear me? Ah, okay. So as you can see now, I have different results. Basically, these are all for channel 11. Well, if I scroll back up, I should see for other channels as well. For example, here we can see results for channel number 1. And I think that's basically it. So as you can see, the results are fetched according to the channels requested. And that's basically it. Does someone have any questions?
This is Hal Roberts, Calix. The channel utilization, they all came back 0. Is that just because this is a quiet environment? And the noise also is 0.
Actually, yeah, the noise is a variable that we had trouble parsing through the NL messages, while the channel utilization, basically because it's lab environments, you shouldn't really see any users connecting to any channels. Any more questions?
So the idea is to port the existing channel selection algorithm from HostCPD into prplMesh, right?
Yeah.
Now, in HostCPD, it will only take into account its own environment because that's the only information it has. In prplMesh, in the controller, you can do a lot more. You can also take into account the other radios. Is there already some idea on how to do that, or is it going to be simply per agent channel selection?
For the first phase, I believe that we will only do the current channel, and I'm not sure regarding the future phases if we'll expand its use further. Currently, we're only going to port the algorithm as is without expanding it furthermore, just to see if we can basically port its functionality to the prpl.
And the current algorithm, does it already take into account that there may be a backhaul link on the same radio so that you can't easily switch channels?
I'm sorry, can you please repeat that? There was a lag.
If there is a backhaul link active on the same radio, if it's a backhaul station active on the same radio, you can't actually switch channels. How is that taken into account?
Well, basically, right now we're at the passive phase, so we're not running an active scan, but we'll take that into consideration once we move forward to the active scan, which allows the channel change.
Well, you can, for scanning you can switch channels, but not for. I mean, if you switch channels, the backhaul link will be broken, right? Because the backhaul link requires that specific channel.
Again, that's an issue we're planning to overcome once we reach the active DCS scan. Right now, we're mainly focused on finishing the passive DCS, which allows gathering of statistic information to pass on to the management system.
Your question is more of how to manage the channel switch for a repeater that uses wireless backhaul. It's in the passive mode, the management of the network is by the third party. So when this the managing will be in the local controller, and the decision making will need to take that into account. But as Itay mentioned, currently it's not actually in the DCS. It's something in the controller. In the beginning of the slideshow, we showed the future plans and the implementation of the decision making in the controller. As part of that, we will need to take in consideration the wireless connection as well.
Well, that can be a technical aspect. At the low level, you can do if you have a hardware that has an additional radio available, or that at one of the chains to one of the antennas has the ability to do to listen on a different channel, you could use that either for DFS scanning, or if it also has the ability to decode demodulate frames, you could use it to do channel scanning of the other channels. If you don't have that capability, you could do very brief switches away from the channel for a few milliseconds at a regular interval to go listen on another channel and try to collect slowly over time some information from there. You could do an active probe that you transmit, which means that you get responses very quickly, and that's even more active scanning that you do, and not so much passive listening on those channels. And you have to take into account possibly the usage on that backhaul channel on which you're jumping away, because you might be dramatically increasing latency over that if you're not available to your stations, or even severely impact the bandwidth if there's a lot of activity going on. So you might want to block it based on the usage of the chain that you notice?
That's actually true. This is part of the implementation, and currently the implementation was on devices that only provide 2 radios, one per band, but there is also a future plan for hardware that supports an additional radio that will be utilized for scans. Regarding the scan per channel, and going back to the active channel, this is exactly what the dwell time parameter stands for. The 30 that Itay provided in the scan request is max of 30 milliseconds staying on each channel when you scan and then going back to the active channel. There are some limitations when you consider DFS channels. This is currently a work in progress because there are some guidelines there that needed to be enforced. And regarding the utilization, you are correct. When we take into account the continuous scans, the interval time is the minimal value of the interval time between scans takes in consideration the utilization time that you must provide according to the specification.
Okay, thanks for clarifying that. And then where would the decision be taken of what to do? Would you, is this something that DW Powell would implement then, and or provide capabilities to the higher layer, information over, do I have an extra radio chain, what can I do with it, etc., or how does that work?
I imagined it will be platform capabilities provided, and prpLMesh will read the capabilities according to the platform. How it will read if it will be configuration or using the WPAL, I'm not sure, so I don't want to.
Yeah, so it might be a configuration that is given to prpLMesh by whoever does the integration on a particular platform with particular wireless.
Yeah, it can be in mode of operation if you have 3 radios and at some point you want to use it for DCS, but on other configuration you might want to use it differently. I imagine the possibilities are varied, but I'm not really sure what currently will be the approach.
Yeah.
But regarding your other question, the enforcement of this utilization and everything, this is something that will be enforced in the application layer. It's, at this point, it's not something that is enforced in the driver. So this is exactly why we have the interval configuration for the application to enforce the interval between the scans.
Yep, that makes sense now. Thanks.
Okay. Is there any other question? Okay, thanks everyone. Thanks, Itay.
Thank you very much.
Thank you.
Thank you.
Okay, that was shorter than I expected.
Yeah.
Okay, then in 15 minutes we have the next presentation by Mario of MaxLinear regarding unit testing. So if you're interested in that, stick around and maybe take a short break now first.